So today in class we talked about ionic versus molecular compounds based on the formula. And what we are going to focus on for the next couple of days is the idea of ionic compounds. So the first thing we have to understand is what an ion is and how they're actually made. So we learned in class today that an ion is a charged particle. Now, what does that word charged particle actually mean? If we look at the formula for an ion, a charged particle means it's either going to have a positive or a negative charge. So some examples of ions that we'll work with a lot in this class are sodium atoms, which make a +1 ion, magnesium, which makes a +2, chlorine, which makes a -1, and oxygen, which makes a -2. So we can see that we have both positive and negative ions. So what we're going to focus on in this lesson is how those ions are made and why the charges are positive or negative. So when we talk about actually making ions, it's all about gaining and losing electrons. And not just any electron, we're gaining and losing valence electrons. And that's really, really important. We learned that that word valence means electrons on the outermost energy level of an atom. So it's those guys that are either being lost or gained. So how do we know the number of valence electrons an atom starts with? There's a nice cheat on the periodic table. If you look at the periodic table, the number of valence electrons that an atom starts with is going to be equal to its group number. And it's those valence electrons that are going to dictate whether electrons are lost or electrons are gained. So let's focus first on how we know how many valence electrons an atom starts with. So if we look at the periodic table, one thing we're going to do is we're going to skip these transition metals. And we'll talk about why that is in a couple of days. So if we start with the alkali metal family, we're going to give them the group number of 1, and we're going to label the rest to the right. So this is group number 1, this is group number 2, this would be group 3, group 4, group 5, group 6, group 7, and group 8. So the number of valence electrons that we have is going to be equal to that group number. So all the guys in group 1 are going to have 1 valence, All these guys in group 2 are going to have 2 valence electrons. All these guys in group 3 are going to have 3 valence electrons. These guys will have 4 valence electrons. These guys will have 5. These guys will have 6. These guys will have 7. And these guys will have 8 valence electrons. So that's going to tell us how many electrons our atom's going to start with before it becomes an ion. Now, why the heck do atoms even make ions? The reason they gain or lose electrons is because their ultimate goal is to have a total of 8 valence electrons. We call 8 valence electrons being octet happy. And that's what every atom on the periodic table wants to achieve, is being octet happy. So the only guys on the entire periodic table who start octet happy are the noble gases. All these other guys are what we call octet upset, meaning they don't have that ideal number of valence electrons. So what they can do is they can either gain electrons or lose electrons to become octet happy. And that's what we're going to investigate in the rest of the video. So point number 1, knowing how many valence electrons an atom starts with. It's going to be equal to the group number. So everything in group 1 starts with 1 valence electron. Everything in group 2 has 2 valence electrons. We've got 3 valence electrons, 4, 5, 6, 7, and 8. And being 8 valence electrons makes you octet happy. That's point number 1. The second thing we're going to focus on in this video is how to determine the number of electrons that are going to be lost or gained by your atom. And we're going to focus on metal ions first. So we're now going to talk about how ions are made. So if I'm a metal ion, meaning I'm any atom that is on the left side of the periodic table, my rule is I'm going to lose electrons to make positive ions called cations. Now, how do you know that positive ions are cations? It's because cats have paws. So your cations are positive. I've known that since I was a sophomore in high school. Hopefully you'll remember too. So let's go ahead and let's look at an example of how a cation is made. And this is going to be the general rule that all your metal atoms are going to follow. So we're going to work with the idea of sodium. So when you're looking at any ion, what you want to identify is how many valence electrons it has, and then how many atoms it's starting with, how many electrons and protons it's starting with. So if we find sodium on our periodic table, it's in group 1. So that tells us that it's going to have one valence electron. The other thing sodium tells us is its atomic number. Its atomic number is 11, and that gives us two pieces of information. It tells us that we have 11 protons in our nucleus, and it also tells us that we start with a total of 11 electrons, because we know that based on the atomic number, that tells us how many positive and negative pieces we have. So this is a Bohr model of the atom, and how we go ahead and represent our electrons is we start by putting 2 electrons in the first energy level, and then we put 8 in the next energy levels after that. So if we're trying to get to a total of 11, we put 2 electrons in the first energy level, we put 8 in the second energy level, and then we put whatever we have left in the third energy level. So I've used 10 electrons, so I'm going to put 1 electron in that outermost energy level. And we can see that that is our same as our 1 valence electron. So every single atom in group 1 is going to have 1 valence electron. So we know that atoms want to be octet happy. So if we look at sodium, it has a decision to make. It can either gain or lose valence electrons in order to become octet happy. So if it wanted to gain electrons, it would need to pull in 7 more pieces to fill this ring, which would be kind of hard for sodium. Or it can simply lose that 1 electron. If it loses this 1 electron, we can see that the energy level below it is full. And that's going to be easier for the sodium atom to do. And that links into the idea of ionization energy from our periodic trends. Because sodium is towards the top of its group and the left side of the periodic table, it's going to have a low ionization energy. So it's going to be able to lose these electrons really easily. So that's exactly what it's going to do. It's going to go ahead and it's going to lose that 1 electron in order to become octet happy. So the electron's lost. Nothing happens to the nucleus. It still has 11 protons. But this time, we only have 10 electrons in our atom. And this is where the positive charge comes from. Because I have 11 positive things in my nucleus and 10 negative things in my energy levels, I now have an overall positive 1 charge for my atom. So when you lose the negative, you become positive. So if I was to lose 2 electrons, I would take on a positive 2 charge. If I was to lose 3 electrons, I would take on a positive 3 charge. So if you're trying to figure out the charge that an atom is going to take on, however many electrons it loses, it's going to take on that positive charge. So if you lose 1 electron, you become a positive 1, because you've got 1 less negative thing now. If you lose 2 electrons, you would take on a positive 2 because you'd have 2 less negative things. And if you take on a positive 3 charge, it's because you've lost 3 negative things. So every single metal is going to lose electrons to make a positive ion called a cation. So that's the first type of ion we can make. The other types of atoms we have on the periodic table are your nonmetals. So nonmetals are going to do the opposite. Your nonmetals are going to gain electrons to make negative ions called anions. Now, I don't have a fun trick to remember that. All that I remember is there's an N in negative and there's an N in anion. So your negative ions are going to be called anions. Now, the example we're going to work with for this guy is fluorine. So if we look at fluorine, fluorine is in group 7. So that means fluorine should have 7 valence electrons. We also can get the atomic number from fluorine on the periodic table, and we know that fluorine's atomic number is 9. So that tells us that fluorine starts with 9 protons and 9 electrons. So if we go ahead and we put those in our Bohr model, we put 2 electrons in the first energy level, and we put 7 electrons in the outermost energy level, because 2 plus 7 gets us to a total of 9. So we can see that our valence electrons is going to be 7 in this case. So again, with fluorine, it has a decision to make. It wants to go ahead and become octet happy. So it can either lose 7 electrons or it can simply gain 1. In this case, adding 1 electron to this atom is going to be much easier than losing 7 electrons. So for your nonmetals, it's going to be much easier for them to gain than to lose. So this guy would take on an electron to go ahead and turn into a fluorine anion. So we can show that with a different colored circle or a filled in circle. So the nucleus again remains unchanged. It still has 9 protons. But this time, since it's gained an electron, it now has a total of 10 electrons in the atom. So we can see here, if we compare the positive and the negative, we've got 9 positive things in the nucleus and 10 negative things in the orbitals. So this guy would take on a -1 charge. So when you gain, you become negative because we've added an extra negative piece. And your negative charge is all going to be impacted by how many negative pieces you're gaining. So if I add 1 negative, I take on a -1. If I add 2 negatives, I would take on a -2. If I add 3 negatives, I would take on a -3. So your charge is all going to be impacted by, am I gaining pieces to become negative, or am I losing pieces to become positive? And whether you gain or lose is all linked into the number of valence electrons that you have. So if we think back to this guy here, we learned that this guy has 1 valence electron. These guys have 2 valence electrons. We skip these. These have 3 valence electrons. These have 4 valence electrons. These have 5 valence electrons, 6 valence electrons, 7 valence electrons, and 8 valence electrons. And we know that our goal is to go ahead and get to 8 valence electrons. So we can figure out the ion charge for an atom based on its number of valence electrons and whether it's a metal or a nonmetal. Because we know metals are always going to lose to make positive ions, and we know nonmetals are always going to gain to make negative anions. So if we look at the periodic table, we know that sodium takes on a +1 charge because it has 1 valence electron to lose. Every other metal in this column is going to do the same thing. So all of these atoms will always take on a +1 charge. Your group 2 are metals that have 2 valence electrons to lose. Since they're metals, they'll always lose. So if these are losing 2, they would take on a +2 charge. If we draw our little zigzag in so we can divide our metals from our nonmetals, aluminum here would have 3 valence electrons, so it would take on a +3. We skip this 4th column. He's special. We'll talk about that a little bit later in the week. And now we can pick it up with the nonmetals on this side of our zigzag line. Because these guys have 5 valence electrons, they're 3 electrons away from 8. So they would want to gain 3 electrons to take on a -3 charge. These guys have 6 valence electrons, so they would want to gain 2 to get to 8. So they would take on a -2 charge. And these guys have 7 valence electrons. They're only 1 away, so they would just take on a -1 charge. So we can use the idea of how many valence electrons we have, plus whether we're a metal that's going to lose or a nonmetal that's going to gain to help us figure out the charge. So if you have 1 valence electron to lose, you'll take on a +1. If you have 2 valence electrons to lose, you'll take on a +2. And if you have 3 valence electrons to lose, you'll take on a +3. For the nonmetals, it's going to take on a negative charge. These guys need 3 more to be octet happy, so they're a -3. These guys need 2 more to be octet happy, so they're a -2. And these guys need 1 more to be octet happy, so they're a -1. So here's what I'd like you guys to try and do tonight. We have these elements. I'd like you to think about the rules that you just learned to see if you can determine the charge that that element's going to take on. I'd also like you to add any questions that you have on your Google form as well, so that way I can start class by addressing those questions. What we're going to focus on tomorrow is just simply how to make ions and what that charge represents. Hope you guys are feeling all right about this. Remember, if you always have questions, I'm here in the morning for help. Have a great day, guys.